Hello all, welcome to Code Hub. Consistency is the key to success. And today let us solve the LeetCode daily challenge. The question is the maximum area of piece of cake of after horizontal and vertical cuts. You are given a rectangular cake of size h into h cross w and the two arrays of integers horizontal cuts and the vertical cuts, where horizontal cuts of I is the distance from the top of the rectangular cake to the ith horizontal cut, and similarly the vertical cuts is the distance from the left of the horizontal cake to the jth vertical cut. Return the maximum area of the piece of cake after you cut at each horizontal and vertical position provided in the arrays horizontal cuts and vertical cuts. The answer may be large, so we have to return it with the modulo 10 power 9 plus 7. So hope the question statement is this. Let us see the example so that you will get a clear understanding what is the expectation. They have given h is 5 and w is 4. So this is a h cross w matrix. Consider it is a h cross w matrix. So that we must they have given the horizontal cuts array and the vertical cuts array. Let us let us see in this what they are doing. Consider they have done horizontal cuts first. In the first index they have done one cut. The next in the second index they have cut this second cut, and the fourth index they have cut the another they have done another horizontal cut. So these are the horizontal cuts that are done for 1, 2 and 4, and similar way we can do the vertical cuts as well. For vertical cuts, first they have done the in the first index, then they have done the third index. So ultimately after doing all these horizontal cuts and the vertical cuts, we have to find the maximum area. Consider in this rectangle, in this square, this is a square. It's what is the area of the square? It is height into width. It is not exactly a square. Consider it as a rectangle. It can be a square or a rectangle. So I will generalize and say it as a rectangle. So to find the area of the rectangle is, the formula is height into width, right? Height into breadth, or I will say it as width itself for here for now. So this is the area of the rectangle. So we have to see whether we can maximize it. We have to maximize it. So for this rectangle, what will be the height? The height is 1 and the width is 2. So the ultimately the area of this rectangle is 2. 2 into 1, 2. For this rectangle it is 1 and the width is 1. So 1 into 1 it is 1. So for this rectangle it is 1. Similarly it is 1, 2, here 1. Consider this. Here the for finding the area of this rectangle, the height is 2 and the width is 1. So the ultimately the area is 2, right? 2 into 1, 2. So consider this. Here the height is 2 and the width is also 2. So the area of the rectangle here will be 2 into 2, it is 4. So we have maximized it. And here it is 2 and here it is 1, here it is 2, here it is 1. So we have, for the brute force approach, we can make all the cuts and we can dry run through all the areas of each rectangles and we have to see the maximize. But why do we need to do that? If we find the maximum of this horizontal cuts, they are adjacents. I am saying they are adjacents. And if I find the maximum width of this vertical cuts, they are adjacent, we can automatically say the maximum height into maximum width gives me the maximum area, right? So that makes sense, right? So we are now just doing we can find the maximum difference, maximum height difference in their adjacents through the formula horizontal cuts of I minus horizontal cuts of I minus 1, right? Consider the array as 1, 2 and 4. So what will be the difference of this segment? It is obviously 1. The maximum height is 1. So what we can do is the maximum height is 1. For now I will say the maximum height to be 1, and I will go for each adjacent and I will find the difference. So we can go to our next segment and we can find the difference. 2 minus 1. 2 minus 1 gives me the height of this segment 1. So it is the maximum height is not gonna update since already the maximum height is 1. We will go to the next segment. Next segment, the maximum height will be 4 minus 2. The height of this segment will be 4 minus 2, right? So 4 minus 2, it is 2. So the maximum height gets updated to 2. And for this segment, we have completed this array. So how we can find the last segment's height? Similarly, how we find the first segment height? We have initialized to 1 itself. This will be the first segment. And for the last segment, we can find by subtracting the height, right? So if we consider the last segment to be 5, 5 is nothing but this h. So h minus the last value gives me the last segment's height. So to find the last segment height is nothing but h minus the horizontal cuts of last value, right, which is nothing but h is 5. 5 minus the last segment's horizontal value is 4. If we find this, the height is 5 and the total h is 5. H 5 minus the last horizontal cut is 4. 5 minus 4 gives me 1. So 1 is the last segment's height. So we will take the maximum of it, but already the 2 is the maximum. We will update it. Now similarly, 1 minute. Now similarly we will find the maximum width of maximum vertical cut with their adjacents. The first how to find the maximum width of this how to find the width of this first segment? It is nothing but the 1 itself, first element itself. We are having the vertical cuts as 1 and 3. So the maximum maximum vertical cut is 1 itself for the first segment. And next we will go and find their difference between the adjacents. 3 minus 1. 3 minus 1, it is 2. So we can maximize, we can update our maximum vertical cut. It is 2. And we can find the last segment. How we will find the last segment's width? The array is finished. We can find the last segment's width by subtracting it with their w. W is nothing but the total matrix column size, right? So 4 minus 3 gives me the maximum 4 minus 3 gives me the width of this last segment. So 4 minus 3 is 1. The maximum vertical cut will not get updated. Now to find the maximum area, what we are going to do is maximum horizontal cut horizontal cuts height into the maximum width of the vertical cut gives me the maximum area, and just we can return our maximum area. Hope you get the logic behind this, and hope you get the intuition how we arrived at this approach. Now we will just code the approach. We will handle some edge cases, not edge cases necessarily, it is some conditions. Let us go and code this approach. First we have to have two variables, which is the maximum cut, maximum height. I will say namely max height, which is initialized to the first value. For this first segment, the first value itself is a maximum cut, right? So we will maximum height. For this vertical cut, the first value itself is the maximum vertical maximum width. So we will take namely we will take this horizontal cuts. I will say H cuts. It will be more easier. V cuts. So the first element will be the maximum height initially. Similarly, we will initialize maximum width, max width to be vertical cuts of 0, which is the first element. Finally, what we are going to do is maximum. We have it will give a wrong answer. We a long answer. We have to return it with modulo. Return the answer with modulo. So I will declare a mod int mod, which is 1e9 plus 7. So this will be the mod value. Consider we can have consider this maximum width to be height, since the constraints is 10 power 9. Since the constraints is 10 power 9, we can get a large value. We can have it as long itself. And finally, what we are going to do is we are going to find the maximum area. How to find the max area? Since the function name itself max area, we will name it as maximum area of cake. Maximum area of cake is nothing but max height into max width modulo mod value with mod value. That's it, right? So this is our maximum area of cake. So we will just return the maximum area of cake, and this is all we are going to answer. Now we can find the maximum height and maximum width through the H cuts and V cuts array. In the second examples, you can see that the horizontal cuts is not in sorted order. If we have in sorted order, we can say it. We can find the maximum difference between their adjacents. So first we have to sort the array. Sort H cuts dot begin, comma H cuts dot end, and similarly we are going to name for V cuts as well. This sort function should be done before initializing our max variable. Now it makes clear, right? After sorting, we will take the maximum height to be the first element and maximum width to be the first element of the V cuts. Now we will calculate the maximum height with their formula. Int I is the we will start from first index. It will go till h cuts dot size I plus plus. How we are going to update our maximum height? HEIGHT is max of max height comma the absolute difference of the current element minus the previous element. So H cuts of I minus H cuts of I minus 1. Hope this is understandable. Max of this. Since it is a long, we will typecast to long as well. And we will similarly we will calculate this for maximum width also. Maximum width will be the maximum of the maximum width or the absolute value of V cuts of I minus V cuts of I minus 1. Here V cuts dot size. And next what we can do is we can we want to find the last segments width also, last segments height also. So we have to update even the max height for the last segment. So max height will be maximum of max height comma absolute difference of h will be the array size, h minus the last cuts value. So h cuts of I will declare this h cuts in some variable so that it will be easier. So the last value I will say it as h size to be h cuts dot size, and similarly v size is equal to v cuts dot size, and I will replace this h cuts dot size with h size and v cuts dot with size with v size, and we have to find the last segment's height by h minus the h cuts of h size minus 1. Similarly, we have to calculate the maximum, we have to update the maximum width also with the, for the last segment. Maximum width will be max of maximum width, comma, absolute difference of w minus v cuts last element of the vertical cuts, v cuts of v size minus 1. Hope you understand this code, and this we can make this as modular too, since we are doing the same here and here. Let us try to complete this problem, and let us try to make this as modular code. We can just do the run code. Oh, I have missed the semicolon. Okay, I'll just run the code. What will be the time complexity for this approach? The time complexity will be the order of 1 minute. No matching function. Yeah, I have said previously, right? We have to do a typecast. So I will make, since maximum function is going to have two variables with same type. One is long and one is int. It will not. It will throw an error. Now we have done a typecast. It got accepted. We will use the example test cases as well. What will be the time complexity for this approach? It will be, since we are doing sorting, it will be maximum of order of h size log h size log h size or else maximum of order of v size, order of v size log v size. So this will be our time complexity, and space complexity is order of 1. So we can generalize it to order of n log n, where will be n will be the maximum of h size comma v size. We can say it as order of n log n, where n will be the equal to maximum of h size comma v size. Hope this will be more clear now. So this will be our time complexity. Here it is our space complexity. We will submit our code. Oh, it got accepted, and hope you like this video. Let us try to make this modular, since it is two function, since two times we are running a for loop, similar times we can just break down into functions. We will try to do that as well. Here I have made this code a little bit modular, since we are doing the same thing twice. What I have initialized is, first I have initialized the h size, which will be the h cuts dot size, and v size will be the v cuts dot size, and then we have to sort the both the arrays. And after sorting, we can we want to find the maximum height, and we have to find the maximum width. So for maximum height, I have generalized and written a function as find max. I will be passing h cuts, h size, and the h. And what I will be doing is just finding the maximum of their adjacents, and then I will return the maximum value. First, I will be initializing the first cut as the adjacent and first cut as the maximum value, and then I will be running a for loop from the first index, and I will be finding the difference between the adjacents, and I will be updating our max. And after finishing the array, we should find the max, update our last segment as well if it is a max. So the total length will be giving the h or w. So h minus the cuts the last value will give me the last segment's height or the width. So I will return our max, and after finding the maximum height and maximum width, I will be calculating the maximum area of the cake through the formula maximum height into maximum width modulo mod. So here the runtime is 156 millisecond. Let us see, after making this as a modular code, let us submit the code and see whether it is. Yeah, it got reduced till to 74 millisecond. You can see how the converting it to a modular code is reducing the time complexity. So let us see in tomorrow's LeetCode daily challenge. Until then, bye. Consistency is the key to success.